The next type of questions I am going to take up are integral 1 over a sin x plus b cos x plus c dx. Now if one of them is 0, say a is 0. If a is 0, this will change into 1 over b cos x plus c. If b is 0, this will change into 1 over a sin x plus c. And if c is 0, this will change into 1 over a sin x plus b cos x. This method is applicable to all these forms. So method is, whenever we see a question of the form integral 1 over a sin x plus b cos x plus c, what we do is put tangent x by 2 equal to t. Put tangent x by 2 equal to t. Now differentiation of tangent is secant square x by 2 and differentiation of inner function is 1 by 2. So its differentiation is secant square x by 2 into 1 by 2 dx is equal to dt. Therefore we can write dx is equal to 2 dt over secant square x by 2. And this is equal to 2 dt over secant square can be written as 1 plus tan square x by 2. So this is equal to 2 dt over 1 plus t square. So dx is equal to 2 dt over 1 plus t square. Now we know sine of x. Sine of x is 2 tangent x by 2 over 1 plus tan square x by 2. Sine x is 2 tangent x by 2 over 1 plus tan square x by 2. This can be written as 2t over 1 plus t square. And cos x can be written as 1 minus tan square x by 2 over 1 plus tan square x by 2 is equal to 1 minus t square over 1 plus t square. Now substitute these values in 1. Substitute in 1, it will reduce to the form 1 over quadratic dx. And this we know how to integrate. What we do is we write this quadratic as sum or difference of two perfect squares and use appropriate formula. So whenever we see a question of this form, we will put tangent x by 2 equal to t. And dx in this case will be 2 dt over 1 plus t square. And we know the formula for sin x is 2 tangent x by 2 over 1 plus tan square x by 2. Therefore sin x is 2t over 1 plus t square. And cos x is 1 minus tangent square x by 2 over 1 plus tan square x by 2. This is equal to 1 minus t square over 1 plus t square. What we notice in all these three, the denominator is 1 plus t square, 1 plus t square, 1 plus t square. This will help you in memorizing these formulae. In all the three we have 1 plus t square, 1 plus t square and 1 plus t square. In sin x we have 2t, in cos x we have 1 minus t square and in dx we have 2 dt over 1 plus t square. Now substitute the sin x, cos x and dx in 1. This will change into 1 over quadratic and we know how to integrate this. Now in a special case when c is 0, that is the question is of the form 1 over a sin x plus b cos x dx. A shortcut is available. A shortcut is available. So what we do in this shortcut is I is equal to integral 1 over a sin x plus b cos x dx. We divide the numerator and denominator by under root a square plus b square. We divide the numerator and denominator by under root a square plus b square. Therefore this can be written as 1 over under root a square plus b square over a over under root a square plus b square sin x plus b over under root a square plus b square cos x. Now if we take a right angle triangle whose this angle is alpha and let this side be a, this be b, then by Pythagoras theorem hypotenuse will be a square plus b square. Therefore a over under root a square plus b square will be equal to sine of alpha perpendicular over hypotenuse. sine of alpha, and b over under root this, b over under root this, base over hypotenuse. This is cos of alpha. So we can write this as sine alpha sine x, cos alpha cos x. So this becomes cos A cos B plus sine A sine B. That is cos A minus B. That is cos x minus alpha dx. And this can be written as secant x minus alpha dx. And we know how to integrate this. Its integration will be log of secant x minus alpha plus tangent x minus alpha. So if c is 0, this shortcut is available. We have to do a very simple step. Divide by under root a square plus b square, both numerator and denominator. Now this thing is common, and this can be written as sine of alpha. Sine alpha sine x, this can be written as cos alpha. Cos alpha cos x. And we get cos A cos B plus sine A sine B is cos of A minus B. And this can be integrated. This can also be written as cos A. If you want to write this as cos, interchange these two sides. Take this as B and this as A. Then this will become cos. Then this question will change into 1 over sine A plus B. 1 over sine x plus alpha. You can also proceed in that manner. But we will fix 1. We are changing this into cos, so we will change this all the questions into cos. Now I take up the first question dependent on this. We will try and memorize that sine x is 2t over 1 plus t square and cos x is 1 minus t square over 1 plus t square. And write them directly here. Only we have to give the step for tangent x by 2 is equal to t, then we have to give these steps. Rest you can directly substitute. Now first question is evaluate the following integrals. First is this. Let this be equal to I. Now this is in the form 1 over a sin x plus b cos x plus c, linear in sine and cos. So what we do is put tangent x by 2 equal to t. Put tangent x by 2 equal to t. Now differentiate this. Differentiation of this is secant square x by 2 into differentiation of inner function is 1 by 2 dx is equal to dt. And therefore we can write dx is equal to 2 dt over secant square x by 2. And secant square x by 2 can be written as 1 plus tan square x by 2. And this is equal to 2 dt over 1 plus t square. Therefore, I can be written as integral. We know that sine of x is 2t over 1 plus t square and cos of x is 1 minus t square over 1 plus t square. I will write them directly in the integral. Therefore, I will be equal to dx. Now, in place of dx, we will write 2 dt over 1 plus t square whole divided by 1 plus sin x. Sin x is 2t over 1 plus t square plus cos of x. Cos of x is 1 minus t square over 1 plus t square. So this question has now changed into a new variable t. Now we solve this question. This is equal to integral. Now LCM of this is 1 plus t square. So 1 plus t square cancels with 1 plus t square. So we will have 2 dt over. Now this is the LCM. So we will have 1 plus t square here plus 2t plus 1 minus t square. And this can be written as integral 2 dt over Now t square cancels with t square. So we are left with 2t plus 2. And this is equal to integral dt over t plus 1. And this can be integrated. This question generally changes into a quadratic. But here t square is cancelling with t square, therefore we are getting linear. But in general we will get a quadratic. And to solve that quadratic, we will write it as sum or difference of two perfect squares and use appropriate formula. So here we integrate this. This will be log of t plus 1 plus c. And t is nothing but tangent x by 2. So we can write this as log of 1 plus tangent x by 2 plus c. So this is the answer. So whenever we see a question of this form, we put a tangent x by 2 equal to t and the question will be solved. Now the problem I am going to take up is I is equal to integral 1 over 1 minus 2 sin x dx. We have linear in sine and cos in the denominator. So what we do is we will put tangent x by 2 equal to t. Put tangent x by 2 equal to t. Now differentiate this, we will get secant square x by 2 into differentiation of inner function, that is 1 by 2 dx is equal to dt. And this implies dx is equal to 2 dt over secant square x by 2. And secant square x by 2 can be written as 1 plus tan square x by 2. And this is equal to 2 dt over 1 plus t square. Now substituting in 1. So 1 implies I is equal to integral. Now in place of dx we have 2 dt over 1 plus t square. So we have 2 dt over 1 plus t square whole divided by 1 minus 2 sin x. So sin of x is 2t over 1 plus t square. I have explained this earlier. You can see the side sheet. So this is equal to integral 2 dt whole divided by, now 1 plus t square is LCM. 1 plus t square is LCM. LCM cancels with LCM. We have 1 plus t square, 1 plus t square minus 4t. So we get I is equal to this much. And this is equal to integral 2 dt over t square minus 4t plus 1. Now this question has changed into 1 over quadratic form. Now to integrate this, what we do is we will express this as sum or difference of two squares. So for doing this, we write t square minus 4t plus 1 is equal to. This can be written as t square minus 4t. To make it a complete square, we will add and subtract half the quotient of t whole square. So half the quotient of t is minus 2. So we will add minus 2 whole square and subtract minus 2 whole square plus 1. And this can be written as this is t minus 2 whole square. T minus 2 whole square. And this will be minus 4 plus 1. That is minus 3. And minus 3 can be written as root 3 whole square. So this is equal to 2 is common, integral dt over t minus 2 whole square minus root 3 whole square. This is equal to 2 into, this is dt over t square minus a square, dx upon x square minus a square. So integration will be 1 by 2a log x minus a over x plus a. So integration of this will be 1 by 2 under root 3 log of x minus a, that is t minus 2 minus root 3 x minus a over t minus 2 plus a, that is root 3. And this can be written as 2 cancels, 1 by root 3 log of t. How much is t? T is tangent x by 2. So this is tangent x by 2 minus root 3 whole divided by tangent x by 2 minus 2 plus root 3 plus c. So this is the answer. Now next question is this. Let this be equal to I. Now again we will substitute tangent x by 2 equal to t. Put tangent x by 2 equal to t. So differential of this will be secant square x by 2 into differential of inner function is 1 by 2. dx is equal to dt. And we can write this as dx is equal to 2 dt whole divided by secant square x by 2. But secant square x by 2 is 1 plus tan square x by 2. Therefore, we can write this as 2 dt over 1 plus t square. And therefore, this question changes into I is equal to integral dx. dx is 2 dt over 1 plus t square. So this is 2 dt over 1 plus t square whole divided by 5 plus 4 cos of x. Cos is 1 minus t square over 1 plus t square. By doing this step, this question will change into integral 1 over quadratic. And we know how to integrate 1 over quadratic. So this question reduces to a known form. So this is equal to integral 2 dt over. Now 1 plus t square is LCM. LCM here is 1 plus t square. So LCM cancels with LCM and we get 5 into 1 plus t square plus 4 into 1 minus t square. And this is equal to, now 2 is common, 2 integral dt over, this is 5t square minus 4t square, quotient of t square, 5 minus 4, 1. So t square is 1. Next we have constant, 5 plus 4 is 9. So we have t square plus 9. And this can be written as 2 into integral dt. Now this is already a sum of two perfect square. So we need not do any step. We can directly write this as t square plus 3 square. Otherwise, this quadratic has to be written as sum or difference of two perfect squares. So this is equal to 2 into, now integration of dt over t square plus a square is 1 by a tan inverse t by a. Integration of dx over x square plus a square is 1 by a tan inverse x by a. So we can write this as 1 by a. 1 by a is 1 by 3 tan inverse t by 3 plus c. So this can be written as 2 by 3 tan inverse t. How much is t? T is tan x by 2. So this is tangent x by 2 over 3 plus c. So this is the answer. Now we take up the third part. Third part is integral 1 over under root 3 sin x minus cos x. But here c is 0. Therefore, a shortcut is available. A shortcut is available. What we will do is divide numerator and denominator by under root 3 whole square plus 1 whole square. That is 2. This will be 3. 3 plus 1 is 4. 4 under the root is 2. So we will divide numerator and denominator by 2. So this will be equal to integral 1 by 2 whole divided by root 3 by 2 sin x minus 1 by 2 cos x. Now we will change this into cos. Now this should become cos alpha and this should become sin alpha. Now sin of theta is root 3 by 2. Therefore theta should be equal to integral 1 by 2 into, and theta must be equal to 60 degrees. That is pi by 3. Sin pi by 3 is root 3 by 2. So this is sin pi by 3. Sin pi by 3 into sin x minus, and this will be equal to cos of pi by 3. Cos of pi by 3. Cos of x dx. In both these places we will get the same angle, and that is the beauty of this method. That's why it is working. So this is equal to integral 1 by 2. So 1 by 2 dx, and this can be written as minus is common. We have cos x cos pi by 3 minus sin x sin pi by 3. So this is equal to 1 by 2 integral dx over minus cos a cos b minus sin a sin b. So this will be cos a plus b. This will be cos of a plus b. That is x plus pi by 3. Cos a plus b is cos a cos b minus sin a sin b. So this is cos a plus b, and this can be written as minus half into integral secant of x plus pi by 3 dx, and this is equal to minus half log of secant x plus pi by 3 plus tangent x plus pi by 3 plus c. So this is the shortcut. When we have a question of the form 1 over a sin x plus minus b cos x, what we do is we divide the numerator and denominator by a square plus b square under the root, which in this case is 2. So divide by 2. Now we must change this into cos. So we must have cos a cos b sin a sin b. Same angle here. If cos theta is half, what will be the value of theta? Value of theta is pi by 3. Cos of pi by 3 is half, and sin of pi by 3 is root 3 by 2. So we can write sin pi by 3 here and cos pi by 3. Now the formula is cos a cos b minus sin a sin b. So we must take one minus common. So this will become cos a cos b minus sin a sign, which is cos of a plus b. This minus is common, so we get this. And integration of secant theta is log secant theta plus tangent theta. So we get this answer. Now you can try these questions yourself. Substitute tangent x by 2 equal to t and simplify. We are providing the answers. You can try these questions yourself. We are providing with the answer.